Hey everyone, let's solve today's GFG problem of the day, that is swap two nibbles in a byte. It's a pretty straightforward problem if you are comfortable with bit manipulation and binary representation of decimal numbers. Okay, now let's look at the actual problem. So you are given a number n and your task is to swap the two nibbles in a byte or in the number. Okay, our number is in the range of 0 to 2 to the power 55, so it can be easily represented with a 8-bit number. Now the question comes, what exactly is a nibble? So if you represent a number in binary format, let's take 100 for example. The group of 4 bits will be called a nibble. So in this number, this will be a nibble, the first 4 bit, and second 4 bit. We have 2 nibbles. Now your task is to swap these two nibbles. Together. Okay. So the resultant number will look something like 0, 1, 0, 0 and then 0, 1, 0, which is equal to 70. So you have to give 70 as the output. Okay, so this is your problem all in all. Now let's try to think how we will approach this problem. It's a very simple problem if you think about it. If you just try to go with a brute force approach, what will you do? You will have to do a couple of steps. Let's try to think about it. First, what we can do is, we can try to generate the binary representation, right? We are given the decimal representation. What's the most basic thing we can do? We can generate its binary representation. So we will generate the binary representation. Okay. Now after that, what is asked from us? We have been asked to swap the nibbles, right? So that's what we will do. We will swap the 4 bits, first 4 bit with the last 4 bit. We'll swap these two things together. So that will be our second step. Swap the nibbles. Okay. And finally, we have to regenerate the swapped decimal number. Okay. We have to regenerate the number. These are the 3 simple steps. If we are able to do, we'll get our answer, right? So let's see how we will generate our bit representation. It's very straightforward how you will generate bits from a given integer. Okay, let's create an array called bits. This bits will store our generated binary representation of a given decimal number. Let's create a size of 8 array. Okay, so 1, 2, 3, 4, 5, 6, 7 and 8. Okay, this is our bits array. I hope I have not generated more. Let's try to put most significant and last significant bits as well. So this will be 7, 6, 5, 4, 3, 2, 1, 0. Now given a number, let's say 100, how you will generate the binary representation of this number? The step is very simple. You will keep dividing it by 2 until and unless it's 0, and keep saving the remainder from least significant bit side to most significant bit side. Okay, so we'll start dividing by 0. First we will store here, then here, here, all the way till most significant bit. Okay, so for 100 it will be divided by 250, remainder 0, so we'll put a 0 here, then 25, 0, 0. You will again divide 25 by 2, that is 12. We are doing integer division, so 25 divided by 2 will be 12, remainder 1, 1, 6, remainder 0, 0, 3, remainder 0, you will put up a 0 here, again divided by 2, you will get 1, 3 divided by 2 is 1, remainder is 1, so you will put 1 here, and 1 divided by 2 is 0 with the remainder of 1. Okay. Now whatever bits are remaining, you will fill it by 0. Since we are representing our number in 8 bits, remaining bits will be filled by 0. Okay, this is our binary representation. So our first step is done. We have generated the binary representation. Now next thing is, we have to swap the nibbles and then regenerate the number, regenerate the decimal number. Now a simple thing you can do is, you can just iterate over the array and swap these, move these 4 bits to the first segment, that is here, and similarly you can move these 4 bits to the last segment, right? Pretty straightforward. This you can do by yourself. I'm pretty sure you will be able to do this by yourself. But what I'm asking is, can we combine these two steps? Can we combine these two steps together? Can we be smart about it? Yes, we can. How? If you see, for generating a decimal number, again, you have to multiply the bits, the given bits, by a prefix, right? And what are those prefix? Prefix are the power of 2 at the place where that number is. What I'm saying is, you have to multiply this by 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, 4, 5, 6, and 7, right? To get decimal number back from this binary representation, you have to multiply again by these prefixes. Now, in our swapped number, in our swapped bits array, what will be the prefix? If we find that directly and multiply in a single step, we can combine these two steps together and generate the answer in a single shot, right? So when we will swap the bits, this will move here, right? This will move in the first part. So what will happen? The bits for this, the prefix for this will be these bits, okay? The prefix for this part will be this part. Similarly, the prefix for this part will be these 4 last numbers, okay? So what I'm saying is, instead of swapping and then regenerating, if we directly multiply this part with this prefix and this part with this prefix, we'll get the answer in a single shot. So what it will become? You will move these 4 things over here in the last part and these 4 in the first part, okay? So the prefix of your new array will become something like, let me write it in a different color. So this will become 2 to the power, will start from here, it will become 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, and for this part, the most significant bit will start from 2 to the power 3, then 2 to the power 2, 1, and 0, right? So if you multiply these bits together, if you multiply these bits together and then you add it up, you will get the answer, okay? Now let's code this approach. It's a pretty straightforward code. Let's quickly code this up. So our first step is to generate the bits, right? Our first step is to generate the bits. And let's say we'll store it in a variable or in a vector called bits. Generate bits. You will pass an input n and the function will be vector int generate bits, input n. Now how you generate a bit? First, for storing the answer, again let's create a variable bits of size 8, all initialized to 0, and while you have the number, if the number is odd, then we will put bits index value as 1, okay? Let me just do this. Let me initialize a variable index which will tell where to store this number. We'll start putting the number from the back side, right? So this will be 7. It will start from 7. Now once we have put the value, we will decrease our index, will move toward the front side, and we will divide our number by 2. So this will generate and give the binary representation. Now comes the prefix swapping. Instead of swapping the number, the bits, will swap the prefix. So how we will do it? Let's initialize our answer variable where we will store our answer, and then let's use a for loop for int I is equal to 4. So if you remember, we were starting from the 4th bit of the number. The second half has to be moved first, right? So I is equal to 4, I less than 8, that is the last bit, I plus plus, and answer plus equal to, each bit we will multiply with the prefix and the corresponding bits index, the corresponding bits value. Now what will be this prefix? So let me create a variable prefix here, and this prefix value will be power of 2, and what will be the power? Will start from 7, right? So you were starting from the second bit, but that was mapping to 7. If I go back to the writing screen, so the third bit will be mapped to 7, fourth will be mapped to 6, 5 and 4, right? So we have to start power from 6, but iteration will start from here, the fourth position in the array. So prefix will be 2 to the power of, let's create one more variable called val, let's say val, which will be 7. Okay, the power of val. You will keep decrementing val as well. So val minus minus, and now once the last nibble has been calculated, you have to calculate the first nibble with the last prefix also, right? So for that you will write for int I is equal to 0, I less than equal to 3 and I plus plus. For this you will do answer plus equal to, again you will multiply with the prefix into bits value. What will be the prefix in this case? Prefix will again be a power of 2 with same val. Since val was constantly decreasing, right? Val was started with 7 and it was constantly decreasing. So we don't need to reinitiate our val variable. And for this we will do val minus minus. And finally we will return the answer. Okay. Finally we'll return the answer. Let's try to compile and run this. Okay, we are getting a error over here. Generate bits was not declared in the scope. Maybe some typo. Generate bits. Let me just put this name here. Okay, a typo for vector. Sorry. Okay, big blunder here. We forgot to return the bits array, the generated bits array. Now again, let's compile and run this. And we are getting the output. Let's submit it. So that will be the intuitive approach for this problem. There is a couple of other ways also in which you can use the bit manipulation techniques, which are not that intuitive. I can create a separate video for that, as this one has gone quite long. So see you in the next one. Thank you.